But we tolerate this tremendous inequality. Now, we have some hints from recent studies of resources. As I said, the earlier history of studies of resources wasn't that inspiring. You know, we weren't seeing effects of per pupil expenditures. But when we look at resources that are proximally linked, closely linked to the quality of instruction, we see effects. And it helps us understand this inequality. So, class size reduction, Tennessee class size experiment. How many people here know about the Tennessee class size experiment? Don't. If you do, a lot of people don't, so I should say something. So in the 80s, late 80s, the state of Tennessee, it was a very interesting situation where one of the state legislators there was fighting very hard for smaller classes in the state of Tennessee. And they were, and I can't remember this person, was it Achilles? It was one of these people, I can't remember who it was. But they had a huge argument and they couldn't get it passed. It was kind of expensive, couldn't pass it, so he said, let's do a study. And this legislator happened to be a social scientist who said, let's make it a randomized experiment. So 80 districts, in 80 schools, kids and teachers were randomly assigned to larger versus smaller classes. And the result of this is, it is the definitive evidence on a very large scale that reducing class size in elementary years can increase student achievement. And Kruger and Diane Whitmore Schanzenbach, who's one of my colleagues at Chicago, did a follow-up study of kids following up into going to college, taking the SAT and going to college. Dramatic reductions in black-white test score, gaps in college going as a result of having a couple of years of smaller classes in elementary school. Really remarkable how much effect it could have. By the way, it won't always have this effect. California adopted a class size reduction policy, tried to reduce classes. They did reduce class sizes, but they didn't think about controlling the quality of instruction in those classes. So you have to think about what you do with those small classes that's going to make a difference. So what happened was districts ended up competing for a finite number of teachers, and in fact the better off districts in California robbed the poorer districts of the high qualified teachers. So you had smaller classes, but you had less qualified people teaching them. You did not have the effect that we saw in Tennessee because other things were not being held constant. And this is one of the big failings of our research. We say something like class size reduction can have an effect, but we don't say what do you have to do to make sure that those smaller classes are organized in such a way that the effect actually occurs. And how do we make sure it happens? Which is what we would normally do, right? You want to, if you know you can have a good effect, you want to know what's the technology that creates that effect and how do we ensure that every kid has it. That's what we have to have, that spirit of making sure that kids get what they need. But class size reduction does show a lot of promise. Another one is teacher experience. We now know from very rigorous studies, and by the way, it's a tricky thing because if you just watch teachers get more experienced, a lot of the more able teachers are leaving the teaching force. So teacher experience is confounded with who's teaching. So you have to have a very careful study to see how this goes. But there's a series of interesting studies showing the teachers who have 0 or 1 years of experience have less of a value added to their kids' achievement. Well, we know who gets those inexperienced teachers because in inner city schools, which are generally more poorly run and less resource intensive, if you're teaching, you have an incentive to get out of those difficult conditions, and because of union contracts, teachers are using their seniority to escape those difficult situations. We don't have the incentives to keep teachers where they're most needed. And so what happens with the experience is that the most well-off kids who rely least on education for their future success are the most likely to get the best teachers in the sense of the most experienced teachers. Now, some people say, well, what we need is incentives to get better teachers, to get teachers to take jobs in more challenging schools and to stay in those schools, and that's a good idea. But if you think about it, that's really not a very good answer because why don't we say, because that says what we should have is equal opportunity to have an inexperienced, ineffective teacher. That's not what we need. We need policies that prevent, where a school has the resources to make sure that kids who have less experienced teachers, there's a complementary effort that makes sure that those kids don't suffer as a result of that. I'm going to talk more about that. I think schools can do that. the school can organize itself to eliminate the association or greatly reduce the association between teacher experience and children's outcomes. So yeah, we need the fairness, but we don't need just equal opportunity for bad teaching. The same thing with teacher knowledge. We see that now. We now are beginning to get some measures of teacher knowledge, and where we do see decent measures, especially in mathematics and especially beyond grade 4, having a knowledgeable teacher, a teacher who has training in mathematics and has subject matter and pedagogical knowledge in mathematics, we know this has an effect. Same point. We know who gets the more knowledgeable teachers. They go to the more advantaged schools. Same point. Therefore, we need policies that equalize access, but no. We need policies also and practices that enable the less experienced and less knowledgeable teachers to get the help they need so that their kids don't suffer and they gain in expertise rapidly. We need to change how our schools are organized. I want to talk about that. This is going to be my last point. But before I do, I want to just say something very briefly about instruction, which is the other sort of advance. So these are pretty recent advances in research that I'm talking about. And I think we have some pretty major advances in research on instruction. And those studies also point to the possibility of increasing the quality of schooling as a way of reducing social and racial inequality. So the early reading, first of all, I think we've gone pretty far beyond the reading wars. If you read the National Reading Panel, if you look at Catherine Snow's National Research Council report on preventing reading difficulties in young children, that having explicit instruction in word decoding for fairly substantial amounts of time is essential for most kids, and especially for most disadvantaged kids. We know that, and that's good. The problem is, and I already mentioned it in respect to Fred Morrison's work, if that's all you do, which is emphasize decoding of familiar text, and you don't introduce rich language into children's education, then later on, when it comes to try to read to learn, comprehension of new text, the kids whose parents have less academic background, those kids are going to then suffer at that later stage. So we've made a gain. We know about how to reliably teach word decoding, and that's crucial, but we have not put it together yet. We haven't put together what we know about language learning and we know about word decoding to guarantee that kids of all backgrounds can comprehend by the end of grade 2 or 3. So it's kind of a half full, half empty. We've learned a lot, but we have a long way to go. Early science, I think, is one of the most interesting areas. I don't know if you talk about this, but in some of this work, Rochelle Gelman, others, is preschool, and some of it's Nancy Romance and others, Nancy Stein. It's early elementary. Here's the basic hypothesis. Get kids involved in really compelling study of science. You know, it could be bugs or dinosaurs or, you know, inclined planes, stuff that kids absolutely love. Engage them. They love it. If you teach it well, they will develop powerful language of science. Words like predict, explain, determine, or, you know, refuting, or alternative explanations, or, you know, new evidence and does the evidence support. All of that kind of logic is so natural for kids who are, let's face it, they're basic little scientists. That's some of the developmental psychology describes kids basically these little tiny experimental sort of these scientists who are always testing their environment, always learning. They love it, and if they need the language to express their own ideas, so the hypothesis is that this kind of science teaching will have a payoff in terms of vocabulary, syntax, and ultimately reading comprehension. I think there's some early evidence that that's true. That the way you get the big gains in vocabulary and syntax and reading comprehension is not necessarily by reading more and more stories during language arts, but doing subject matter instruction, in this case science instruction, in a way that is consciously organized to promote those things, which those aspects of language are the very things that the kids who are most disadvantaged are least likely to get because their parents don't have education. They have language that's perfectly useful, but for the kind of language you need to be successful in academe, you know, this seems to be a powerful strategy. But we're not doing that because we don't think about how to coordinate science and history and so forth with language learning and math. We put those in different silos and we don't really organize that. And then I'll just say something quickly about math. We have better evidence now that having a decent math curriculum, we have some randomized experiments showing that having a good math curriculum makes a difference. But what we don't have is the kind of support teachers need in how you actually enact that curriculum, how you assess kids formatively so you know how much they're learning, and how you use the formative assessments to guide your next steps. We just have these books, and the teachers who themselves, many of whom don't have great mathematical educations to say the least, are left to their own devices to figure out how to make this system work. We need more instructional guidance for teachers so that they can think about how to interact with their kids, and they don't have to invent the curriculum, and they don't have to invent the formative assessments themselves. It's just too much to ask. You wouldn't ask a doctor to invent a whole technology for every disease, for every time a patient comes in. You would have a lot of support, a lot of data, and a lot of guidance in order to help that person do the job.